Okay, we are on page 16 in the chapter 16 packet, and you should also have your periodic table out. We are going to work on naming binary ionic compounds, and remember, ionic compounds are compounds where electrons are transferred, and in this case, on this page, it's always going to be a metal that is donating electrons to a nonmetal. So the metal ends up with a positive oxidation number, and the nonmetal ends up with a negative oxidation number. When you want to name binary ionic compounds, always start with the metal. So for an example of number 1, it says barium or BaCl2. You find Ba on the periodic table, and it is barium. It is in the second column, atomic number 56. Now when you look at barium, notice there are no small numbers in the upper right hand corner of that box. So look at your periodic table, find barium, and there are no numbers in the upper right hand corner. So what that is telling you is that barium is an easier one to write. We just write the metal how it is. It stays as barium. Now you find Cl on the periodic table. It's in the second to last column. It's chlorine. But what we have to do is change the ending to "ide," so it becomes chloride. Whenever you are naming a binary ionic compound, the ending will always be IDE. If we look at number 2, you have NaF. You find Na on the periodic table. It is sodium. There are no small numbers in the upper right hand corner, so it just stays as sodium, and F is fluorine, so we write that as fluoride, again making sure it ends in IDE. For number 3, you have Ag2O. Find Ag on the periodic table. It is silver. Make sure you look at that. Atomic number 47. You see in the upper right hand corner how it has that number 1. So what it says on your periodic table, you have Ag and you have that 1 in the upper right hand corner. That 1 is telling you that silver always has a positive 1 oxidation number, which means this is another easy one to name. You can just write silver. You find O on the periodic table, it's oxygen, and that one becomes oxide, again ending in IDE. Now I want to jump up to number 12, for example. CrCl2. Now this one's going to be a little more difficult. You have to find Cr on the periodic table. It is chromium. It is atomic number 24. And look on your periodic table. It has 3 numbers in the upper right hand corner. It has a 6, 3, 2. That is telling you that chromium has 3 different possible oxidation numbers. It could be a +6, a +3, or a +2. And we have to know which one that is to be able to write out this name. You cannot just write chromium chloride. It does not give enough information. So what I like to do when I'm doing one of these, consider this element to be kind of split in half. You have the positive on the left, you have the negative on the right. Now you have to know one of those two to be able to figure out the other one. And we know what the oxidation number of chlorine is. It is a Cl with a -1 charge. Right? That's what we did with the oxidation numbers. It's just the oxidation number of chlorine. Now you have 2 chlorines. That's what that subscript is telling you, Cl2. So what this is telling you is you have 2 chlorines. Each one is donating a -1 charge, which means the right-hand side is a total of -2. Now that means the left-hand side has to be +2 to balance it out, because these things have to remain electrically neutral. Now there is no subscript with the chromium, so that whole +2 charge is coming from that 1 chromium. So now that's telling you it is chromium 2. So when we write this, you keep the name chromium, you put the 2 as a Roman numeral, and then you write the chloride just like we have been doing, with it ending in IDE. When you look at the one directly below it, CrCl3, well now we have to do the same thing. We have to figure out which chromium it is, because it could be +2, +3, or +2. So we're working with chlorine again, which is a -1 oxidation number, but now there are 3 of them. So you get a total of -3 on the right-hand side, which means the left-hand side has to be +3. Now there's only one chromium in there, so that whole +3 charge is coming from that one chromium. Now what you have in this case is chromium 3 chloride. Again, ending in IDE because it is a binary ionic compound. So when you are naming ionic compounds, always look at the metal first on the periodic table. If you have an example like barium or sodium or silver, they only have one possible oxidation number. So you do not need any Roman numerals. You just write the name of the metal and then the nonmetal, and you change the ending of the nonmetal to IDE. If you have a metal that is multivalent, which means it has more than one possible oxidation number, you have to make a note of it. So that is why for number 12 we wrote a chromium 2, and number 13 we did chromium 3. If you look at number 4, for example, CuBr, copper can either be +2 or +1, so we have to say which one it is. Bromine we know is -1. There's only one of them, so that means that right-hand side is a total of -1. So the left-hand side has to be a +1 to balance it out. So that is telling us that that copper has a +1 charge. So you write it as copper 1 bromide. Okay, I scrolled down a little bit because I wanted to do examples 6 and 7 with you. They both have iron in them. Now find iron on the periodic table. It is atomic number 26. It could be either +2 or +3, and that is what the little numbers in the upper right-hand corner tell you. So we have to figure out which ones these are. You can't just say iron oxide because then you wouldn't know if it is number 6 or number 7, FeO or Fe2O3. So starting with number 6, we know what oxygen is. It is a -2 charge. Now there's only one oxygen in there, so that means that whole right-hand side is a -2, which means the left-hand side has to balance it out with a +2. There's only one iron, so you get iron 2 oxide. Again, remember to end it in IDE. The endings are very important because we're going to do polyatomic ions and we're going to do covalent bonding, and they have different endings, so you have to pay attention to the ending. Now for number 7, you have Fe2O3. So we have to go through this again. Oxygen is -2, but now you have 3 of them. So each of those 3 oxygens is supplying a -2 charge, which means you end up with a -6 overall on the right, which means the left-hand side with the metal has to be +6 to balance it out. Now, there are 2 irons giving you a total of +6, so that means each iron gives you a +3, right? Because each one is supplying +3, so overall, since there's 2 of them, you get a +6. So now this one is iron 3 oxide, again ending in IDE. So when you are naming binary ionic compounds, make sure you go to the periodic table first, look at the metal, and see if it has more than one possible oxidation number. So if we look at number 8, for example, MgS, Mg is in the second column. It does not have more than one oxidation number. So it's easier. You get magnesium. There is no need for a Roman numeral because magnesium only has the option of being a +2, so we don't have to make note of any oxidation numbers. S is sulfur, and that becomes sulfide. Okay, what you should do now is finish page 16 using Roman numerals when you need them, and remember, they all end in IDE.